Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. You know, I thought I would edit last night's telescope session. It was at 11 o'clock p.m. my time, so it was really quite late, especially for those folks in Europe. And I thought I'd kind of clean it up a little bit and shorten it and give you guys a chance to see what we did last night. So let's dive right in. So, what we're doing tonight, boy, we've got a good night for you. The image you're looking at right now is Arcturus, which is, one of the brighter stars in the eastern sky right now here in Michigan. We're trying first light with a brand new telescope, and that is what is called a StellarVue SV80, and it is an 80 millimeter doublet. Now, the Orion Eon that I have is called a triplet, and what that does is that takes the red, green, and blue light and it focuses them all so that they all come to the same focus point at once. So that's a better scope than this one is. This one has two lenses in it, and it just hits two of the lights, so one of them may be out, and you may see some halos around some of the brighter objects. I don't really see one around Arcturus right now. But it's not quite as good a scope as the Orion. But I'll tell you, I've been kind of playing with this over the last couple of days, and it's got some really nice optics in it, and it's a lot smaller than the Orion is. It's on my Explore Scientific Exos 2 mount right now. The problem that the former owner, Sean Hawkins, had with this one is I think that he had too much scope and too little mount on it. I have too much mount and too little scope. I'm actually having problems with the weights, and I had to put some weight on the telescope to get the scope to balance properly. But it really handles it nice. And the other day when I did some initial tests with this, I was able to get clear 3-minute images, and one of which is on the community section on my YouTube page. And I mean, it really, really turned out nice. There's, the stars are all nice and pinpoint. There's a satellite right there. You see that down the corner? But the stars were really pinpoint, even on a 3-minute exposure. So I have a lot of hope for this one. Plus, it'll be a very nice travel scope, and I can use it with the cadets. This is something that I can move around a lot easier than I can that damn 10-inch Meade. It's just absolutely, that thing is just way too big to be handling around, manhandling around, in the back of the truck and stuff. So I'm using a really moderate amount of gain on this, only about 290 out of 570, and it's only a 1-second exposure. And look at all these beautiful stars out here. Let's go ahead. Now I'm locked on to Arcturus right now, and as you see, the tracking and the sighting is really, really good. But let's go ahead and go over to something else that's a little more fun to look at. So let's go ahead and do a quick test here of Stellarium. We'll bring that up. So here we are. Let's go ahead and go on over to Bode's galaxy, just the Bode's and Cigar galaxies. These are some of the targets that I was looking at the other day here. So let's go see if this will slew properly. And she's moving. How do you like that? We have movement. We'll just sit here and play with it a little bit. Now, I'm going to do a couple of things tonight. I've got a tripod for my auto level and a tripod for the mount that Sean sent me as well. And that's an Ioptron. And it's a little battery-powered mount with a 12-volt converter on it. And that's going to be really super, and I think it's going to be just perfect for my Canon camera. Now, the Canon has got a focal length of 300 millimeters. This telescope has a focal length of 550 millimeters, and the Orion has a focal length of about 700 millimeters, by the time everything gets all done with it. So let's go see if we can see Bode's here. And there it is. There's the Cigar Galaxy, and there's Bode's. To be honest with you, for a near across-the-sky slew, look how close I came to dead set center. Now, let's have a little fun with this. let's just see what we have here. Let's go ahead and do one quick thing real quick. I'm going to give a little bit longer exposure. Everything right there? Yeah, that's all. I'm happy with all that. Let's do a 4-second exposure here and just kind of bring it up, because there's the Cigar Galaxy. There's Bode's Galaxy, and there's the Garland Galaxy right up there. So let's see if we can bring this a little more closer to the center. And I'll show you a neat trick for doing that. Let's go ahead and take this off. This is something that I've started playing with a little bit in astrophotography tool. So what we're going to do here is let's go ahead and connect that camera again. And we're going to shoot a shot real quick. So we'll give it a second. You can always tell it's a 10-second exposure, so you can see up here what it's doing. And there it is. So there is the Garland, there's Bode's, and there's the Cigar Galaxy. Now this is the neat little trick that I wanted to show you. You guys are familiar with plate solving, and we've done that many times before, so we'll solve this plate real quick. All right, so now it's happy. It knows exactly where it is. We're going to hit aim. Let's see whether or not it has to be maximized here to do it. Ah, that's what I want. Now you see right here, if I put this about right here, I'm going to get these. If I put that in the center, if I move everything over so that point is in the center, that'll frame everything really nice. So we'll hit Go to plus. And then let's watch the magic occur. So what it's going to do is it's going to solve. It's going to make the telescope slew a little bit, and it's going to try and move that spot that I designated right to the very center of the frame. So I don't have to tweak the little arrows or anything. And there it is. Look at that. I like that little thing. So let's disconnect that camera and come on back down here. Let's go back to this one here. We'll connect our main camera again. This is the camera that Wolfie donated to the channel. Want to also acknowledge that Judy's out in the audience right now. Judy is a big supporter of this channel. She helped me out with a lot of the mounts for the big telescope. And it's just really been a good friend of this channel. Going to try and raise a little bit of funds. I want to try and raise about $200 and get a couple of other things. So if you guys feel the need to super chat or anything, that would be just super. And here we are. So here's the Garland Galaxy. Here's Bode's. And here's the Cigar Galaxy. Now the next thing that I want to do is I want to go ahead and start guiding this image. All right. So what we'll do is we'll go ahead and hook the guide camera up. Get rid of all of that. Let's go ahead and start looping here. And we're going to find a star to guide on. All right, we got a star to guide on. And we're going to hit start guiding. So we're guiding right now. Going to stick this out of the way here a little bit. Never mind that. So it's going to guide on this star right here, which actually I think might be the Garland Galaxy. And then we're going to have a look here and see how carefully it's guiding. You see where the scope is pointing? You know, here it's trying to track that one star that we're set, and here are the little corrections that need to be made. So let's see how accurate this is guiding. Look at that. The RMS error needs to be under 0.5. So you see right ascension is 0.11, declination is 0.04, and the total is 0.17. Look at these things are staying right where we need to be. There's a satellite just went by the way. So now we're set up to have some fun here. Let's go ahead and take the stretch off of this and have a look at our histogram right here. Now, if you look at this histogram, here's the data that the camera is reading. Now you see it's got this little slope right here, but you see how this left side is clipped on the side? What we want to do is we want to move this whole thing over a little bit so that that is not clipped. And the way we move it over is by doing a longer exposure. So here, let's go ahead and do a 30-second exposure and see what that looks like. And while we do that, I'm going to go on up there and have a look at the chat real quick, see what we have. Let's see, we got Judy and we got IB in Discord. Anybody else come into Discord, guys? Here's the link if you guys want if you want to go on in and get involved in chat. We got Fred Bailey, was one of our early viewers here and helped us get things set up. Darren is out here. Renee, welcome Renee. And Facty, and NANA was here a little bit earlier. Mitch is here. And Fiegelheimer is here. Yeah, I love it when everything comes together for the astrophotography too. It's a lot less frustrating. You know, one of the secrets is just restart the computer before you do anything. Restart both the computers, the one that's out by the telescope and restart the one that's in here. So let's have a look at this image real quick. First of all, look at the stars. You see how they're nice pinpoints? The telescope is really tracking nicely. And we've got the Garland here, we've got Bodes, and then we have the Cigar Galaxy. And the cool thing about it is on the Cigar Galaxy, you're starting to see a little bit of that red. Let's see if we can get a little longer exposure. Let's get risky here and try for a full minute. And Cito, that must be Feigenheimer. Now the colors are off a little bit right now, and the reason that the colors are a little bit off is that you know, there's light pollution out here. I'm in a Borley 4 sky in a small town here in Michigan. So I do have some light pollution out here, even though I have a light pollution filter, but that adds a little bit of a green tint to the image as well. We're going to correct the color balance on the image here in a minute when we do some stacking, and we're going to try and maybe stack a few images of these galaxies. Now let's see whether or not it's going to track nicely. What I'm looking for is nice round little stars. I don't want to see streaks. And really, that's not bad. You're starting to get some nice detail here, especially in Bodes. You see the two kind of spiral arms out here? Getting a little bit of that red in there. Well, you see how the color balance is off, though? Let's do a quick stretch and see what we have here. So I'm wondering if that might be another little galaxy right up there. But you see how we're getting nice, round little stars? Let's do a little bit of stacking and see how that looks. And we'll see if we can get a little better color in this. So what we're going to do, I'm just going to call this Bode triplet. And we're going to go ahead and hit live stack. So let's zero it all out real quick. Yeah, let's go see if we can get an image here. Should be one coming up now. There we go. Now, you see how we got all this crappy green, and look at the, you know, here's the red peak, here's the blue peak, here's the green peak, and this white peak is luminescence, which, you know, has to do with how bright the picture is. Now, By hitting the lightning bolt over here, we're going to balance these peaks together. And already you see a huge improvement. Now the other thing is the data from the image is on these curves right here. There's no sense in wasting sensor out in here. There's no sense in wasting sensor down here in the bottom part of the image, because that's, you know, just this red nasty stuff, and you see the amp glow right up here. Let's go ahead and kind of zero in a little bit better on that image. We want the black level, which is this left dotted line right here. We want that just to the left of that peak. Now the mid-range, we want to get down and probably in the bottom third of this curve a little bit. Let's bring it right out to here and see what that looks like. Already getting a little better image. Now you see the graininess of this image. Let's go see if we can get a couple of images stacked. Now for some reason it stacked the first image, but it didn't stack the second image, and these are 60-second exposures. So let's give it a chance to do one more here real quick, and we're going to see whether or not it stacks it or ignores it. If it ignores it, there's something wrong with our settings up here, our alignment settings and our stacking, and we'll have to play with that a little bit. So here's the moment of truth. Nope, didn't do it. All right, we've got a lot of stars here. That's looking good. Let's go ahead and clear that and let it start over again real quick, because I don't see anything in here that would cause a problem. Bring the black threshold up. We've got lots of stars. We've got good focus. Bring the noise reduction. Minimum star. Let's bring that down to 2. Let's see if that'll give us a little better stack. Now we're not going to change any of these settings because we haven't changed the camera settings at all. Okay, so let's stack that one. The moment of truth is going to be the next one. Now, one thing that you can do to make these images an awful lot better is you can do what's called dark frames, which will get rid of this amp glow up here. And you can do flats, which will get rid of any of the unevenness and the vignetting. You know, sometimes these outer edges of the image will be darker than the central images, like an old-timey photograph. The way you do that, the way you do dark images is you put the lens cap on the telescope, and you take probably 20 images. You know, I'm taking 60-second exposures, so it would take me 20 minutes to do the darks. Now, the flats are a lot easier. You kind of get those before the sun goes down, and you put a white t-shirt over the end of the telescope, and you take really short exposures, maybe 500 or 1,000 of them. Yep, it's stacking now. You see that? And what that'll do is get rid of all the vignetting. Now, the other thing that it's going to do too is something called sigma clipping. So say out of all of these images, I get a satellite that runs right through the middle of it. It's going to recognize that we've got stars, we've got these galaxies, we've got, you know, this amp glow. These are consistent from image to image. But if you get one streak where you get a satellite going through, it's going to say, hey, that's not noise. That's not supposed to be in the image. We're going to average that one out. You know, we're going to kind of bias that one out so that you don't see that streak, and it'll get rid of satellite streaks. And with as many satellites as we have up there, sometimes that's really helpful. So what we'll do is we'll stack 4 or 5 of these things, and then I'll come back and we'll revisit this a little bit and see how that's kind of tightening up a little bit and getting a little bit better. Here, we'll kind of move that over a little bit now. You see where this comes down steeply and then it evens out? I think the best place for that is just after it starts to flatten out a little bit. You see that image is already getting better, and we've only got 3 images. Oh, something happened to PhD too. Something weird. Well, it says it's guiding. Let's go ahead and just close that and restart it just in case there's a problem with PhD 2. Then we'll have a look at a couple of things that I'd like to try and find tonight. I thought we'd start off with a nice easy image of Bodes and the cigar because they're nice looking galaxies, and the cool thing about this shorter exposure, or this wider field in the shorter focal length telescope, is that you get, for example, I've got all 3 galaxies in this image. Now with the Meade, I can barely fit Bode in, and the cigar galaxy takes up almost the entire frame. But with the shorter focal length, I can get all 3 galaxies in here, and I'm thinking that's something right up there too. Since we're in the process of taking images right now. Yeah, we're getting, that's absolutely fantastic guiding. Okay, there's Stellarium.
Do you have it set to dither as well?
Yep, it's going to dither. It's going to dither about every 3 images. What Ivy's talking about with dithering is that what it'll do is, say the camera's pointing right here. Now, every couple of images, what it's going to do is it's going to shift the telescope so that now the camera's pointing 3 pixels over this way. And then it'll shift it so it's pointing 3 pixels up this way. What it does is it kind of switches, it kind of moves the telescope around a little bit. And the noise that we're getting in the background of that image, which you can see pretty clearly. See how this is all grainy in here and it looks like it's got red sand all over it? What happens with dithering is as it moves over a little bit, these little red grains of sand are next to little black areas of the background. And what they'll do is they'll kind of blend into each other and cancel each other out, and this will all turn black in the background. Just gives you a little bit better of an image. All right, so here's Cigar, here's Bodes, here's the Garland. I'm wondering what this little boy is out here. Let's go see if we can find anything in that area. So here's the Cigar, here's Bodes, here's Garland. I don't see anything else other than maybe this star right here seems to be a little bit larger than some of the other ones. But that other thing that we're looking at's right up in this area. I think it's probably just that big star. You see all the red that comes out of the Cigar Galaxy, and it's got these jets going up and down. Here's the Bodes Galaxy, a really nice spiral galaxy. That's a smaller spiral galaxy right there. Bodes is kind of interesting because, I don't know if it's a barred galaxy or not, but it seems to have 2 big arms, one that comes around that way, and then one that comes out the other end and goes around that way. And you can see that on the image that we're taking right now a little easier. See how there's an arm that comes around this way, and then there's another one that goes around like that. Let's go see what we have. DJ Moose, we've got Judy, you've got another Finlander out there. Oh.
We have a few more in the Discord as well.
Good. Hey guys, welcome. So Mitch, don't you temporarily drop the exposure time so you can get a couple more short frames to make sure it works? Yeah, of course. I know you never test anything, you never take a 5 minute exposure just to see if things work. What you can
Yeah,
do is
I'm
you
an
can,
impatient.
yeah, I don't have that patience. What I do is I'll drop it down to, especially in something like this where I've got a couple of bright stars out there. Um, I'll take a couple of short exposures just to kind of, oh, that's a little better right there. Come on.
That's looking pretty good.
Yeah, that is looking pretty good. You see how we're starting to get different. This camera's got a lot of red in it. But you see that, looking at that thing, it almost looks like the graininess has gone away a little bit too. Look at the detail that we're starting to get. Look at the dust lanes. You can see the dust lanes in there?
I got my Atlas downstairs. I think that's an NGC object up there in the
That one?
left or the upper right.
Yeah, it could be.
But I'm too lazy to go down 2 flights of stairs and back up to go get it.
Well, dude, here we go. Hang on.
I did see Bob's last community picture. That was just beautiful.
Yeah, and that was, I got to tell you something. That was a shitty picture. You see the big red streaks in it?
I
just
don't understand
dithered.
anything of what you're doing, but it is fantastic that you can bring them into focus.
All right.
Faraway galaxies like this. Badass.
Yeah. But here's basically what we're looking at. Okay? So here's the framing of our picture. For some reason, it's upside down. I don't know why, because we're actually looking at it. Cigars at the bottom. There's bodes. There's garlands. And then that thing right there is what we're looking at. It says it's a star. But that's what we're looking at right there. And I can show you that real quick. So, cigar, bodes, garland, boom. That's the object that we're looking at, and it says it's a star. Just almost looks like it's got a little streak on it. And that didn't turn out too bad. Those are 1 minute exposures. And look at these stars. They're nice and round. I don't see any, it's not streaking or anything. So you see, this is a really, a lot of people get what's called aperture fever. You get out to the star party and then you have an and you get a bunch of middle-aged guys together out there and they have an aperture measuring contest. And, the guy that's got the 8-inch telescope, some guy's got to come out and have a 10-inch telescope and then a 12 and then a 14. And the biggest telescope that amateurs probably, just due to the physics of light and everything and the mounts, anything over about a 16-inch telescope is, yeah, you're getting the telescope for something other than what it was designed to do, and that is take good images. You just want to have the biggest, you want to be the biggest, you want to be a big man on campus. Now, there are some people that can use those really large ones. I'm not one of them. But the thing about it...
At Stanford Astronomical Society, they had a 19-inch Dob, and that was about 9 feet tall. And the objective was high so that you had to get on a step ladder, a rolling step ladder, to look at the scope. Now, it was a great scope, and the detail was amazing. Saturn was phenomenal in a 19-inch Dob. The problem is, the field is so small, stuff just tracks away. So by the time 2 or 3 people get a look at an object, you have to readjust it.
Well, the other thing with a Dob,
tracking system,
you can't put a Dob that size. When you start looking at actual observatories that have these monster equatorial mounts and, really, $1 million cameras and things like that are reading the images, that's a whole different level. When you look at, throwing something in the back of the truck and going out to a dark site.
Yeah.
You know, if you want to get an aperture that big, unless you want to mortgage your house, you're going to end up with a Dobsonian. And Dobsonians are not put on equatorial mounts. They're put on alt-az mounts. And trying to get astrophotography with a big Dob, or doing go-to or tracking with something like that, you know, with an equatorial mount, you're tracking in right ascension only. Your declination is already set, and since you're polar aligned, all you have to do is track in one axis, and that's right ascension. With an alt-az mount, you have to track in both declination and right ascension. And what you do is you get a series of little stair steps.
Right.
And you're limited to about 30-second exposures. That looks damn good.
Well, it sort of makes sense too. Those really big scopes like that are usually bought primarily for visual astronomy.
Yeah, visual astronomy, you don't worry about it as much.
Yeah, they get those big apertures so they could actually see the color.
Yeah.
Which they can't normally see with smaller scopes.
Well, the nice thing about it. Where is my? How come my stacks aren't showing up? There we go.
All right, Bob, we're heading to bed.
All
Sorry,
right.
I can't stay up late tonight, but it's great seeing you guys.
Yeah.
We'll catch you again sometime.
Good night.
Good night, man. Let's let this stack one more time. And then what I'm going to do is I'm going to capture this, and we're going to start looking at some other things here real quick. Let's see if we get 4 captures. Come on. I don't think that's capturing anymore. We'll go ahead and hang on to that one. And then, okay, so I've got an image right now. This is a 3-minute image of these. And what I'll do is I'll send that on up. But that's the image that we just took. So let's stop our
Very
live.
clean now.
I mean, that's not bad for 3
That's really
images.
clean.
Yeah. And that's what I was getting at with the shorter focal length wide field scopes. You know, a 20-inch Dobsonian, you're going to get that right there. That's all you're going to get. But with a shorter focal length and the smaller scope like I'm using right now, not only does it weigh 5 pounds, all right? I mean, the mount is 4 or 5 times heavier than the scope is and all the equipment that's on it. But look at the huge amount of relationship that I get between all of these galaxies. This will come in really nicely here. Let's go ahead and have a look at the Gemini cluster or the Virgo cluster real quick. I mean, we're going to see 20 galaxies in this short of an area. So that was just kind of a test shot. Markarian's chain. It's out in Virgo. And, you know, look at all of these galaxies that we're going to see out here. So let's go ahead and head on over there. Come on, move. See the little satellites going? See those 2 little satellites going up there?
I was about to ask about satellites. Wouldn't they be like a little pinpoint of light that walks across the sky there?
Well, that's what they look like out here in Stellarium.
Yeah.
Funny you should mention satellites, because we're going to have a look at a couple of them here in a minute.
I saw the Starlink ones the other night. I didn't know what I was looking at first.
Kind of funky, wasn't it?
Yeah, I looked up in the sky. I said, "What the heck is that?"
That would be the
And
Starlink chain.
somebody just walking by on the street told me that's the Starlink.
Yeah,
Didn't
there's
know
up
they
to
launched. I
60 of
said,
them.
"No." Yeah,
I'll tell you what,
I
since
thought it
you
was
asked
something
about it,
coming into the atmosphere, but then I realized it wasn't behaving normally like a meteorite would.
nope. And there's not
Yeah, so I'm
60
like,
of
"What
them
is
lined
that?"
up.
I stopped.
I'm kind of curious. I tried looking at some satellites the other day and it was doing some funky things. So it says the time zone's not matching. Let's see if it's a little bit happier here. Now, this is a geostationary satellite, Amazonas 5, and it's located right here. So here's me. Here's the satellite. It says it's in sunlit right now, so we should be dead on it. Our little circle of view comes down and surrounds the satellite and turns green, which means that we should see it. Let's go see if we can see some satellites here. Now, to see satellites, what you want to do is you want to get about a 15-second exposure. That seems to be locked up a little bit. Let's go ahead and just stop SharpCap and we'll come up again. I just want to see if we can get an image with this. We may have to restart it. Now, I live on a lake, which means that there is a lot of moisture in the air out there. It's cold tonight. We're not, the dew point and the ambient temperature is not far apart. I've got a dew heater on the telescope right now. See, it's doing that. It's not doing it right. So we're going to restart the computer real quick. This is the way I do this real quick, by the way. The broadcast computer is my Apple here in my office. And I have a LAN cable running from my router to a laptop that's out in the yard next to the computer. And what I do is I take it over with something called Google Chrome Remote Desktop. Wolfie's starting to do this down in Australia, but I've been doing it since the winter because, quite frankly, it's too damn cold to be out there. So here's the setup that I have. This is just my laptop, my work laptop. But Telescope Control and Telescope Control 2, these are two nearly identical Windows machines. These are little laptops that, I used to use as my primary computer many, many years ago. I went ahead and had them upgraded with some memory. They both have 16 gigs of memory now. They've got solid state drives now. And they also, just have Windows 10. So it's very easy to go ahead and take over that computer. So this is what's going on in my yard right now. We'll go over here. And all of my little telescope programs are right here. The first thing that we do is we start up Ascom. Ascom is the software that allows all of the astronomy equipment to talk to each other. Now, typically what will happen is I'll hit connect and it'll give me an error. Okay, so unable to write to telescope. Then I'll do it again. It'll give me a second error, which is a little different. And I'll hit OK on that. Third time's generally the charm. And there you go. Unpark the scope. Now we've got to start a couple of programs over here. One is Stellarium. One is SharpCap. And one is something called astrophotography tool. Stellarium is the planetarium software that we were looking at a minute ago. SharpCap is the good imaging software. And astrophotography tool is what we use for plate solving. Now, the other program that we occasionally use is PhD2, which is the guiding program. But let's go ahead and get all these guys talking to each other. So, in Stellarium, go down to Telescope Control and select the Ascom telescope, which in my case, these are all Ascom telescopes, but I'm using this particular mount. So by connecting that, ideally what'll happen is it'll show me where the mount's looking. Come on. And I have no idea where it's looking right now. Okay, so there's where it's looking. I'm thinking that that's probably not where it's supposed to be. But we'll see here in a minute. So let's just make this smaller. Now SharpCap, what we'll do is we'll bring up the ZWO 120 is the guide camera, and the 294 is the color one-shot camera. Now a couple of settings that you do over here is instead of having RAW 8, which is for short exposures, you want RAW 16. That means it's color, and it's 16-bit. Binning you can change. This camera can go from 1 to 4. Binning, you know, and that's kind of a way to average it and get rid of some of the garbage on it. We're not worried about that right now, though. I'm going to take a 15-second exposure, and our gain is set at 295. I'm happy with that. And it looks like it's taking the full exposure now, you see? One of the things with astrophotography is occasionally things just freaking quit. Ah, all right. You wanted your answers. I like this. See the streaks? Those are the stars. Okay? These dots are all satellites. There's 6 of them right there. That's really, really nice. See how the telescope is tracking the dots? And the stars are moving past it?
Yep. I had to wait on the video delay, but I see it.
Yep. Sorry about that, man.
No, that's good. That's what I meant, though, that, you know, when you lock onto a satellite, it's just going to be a solid pinpoint.
Yep. Exactly.
Yeah.
Now, let me just finish doing a couple of things here real quick. Well, guys, trivia question for you. What happens when your dew point and your ambient temperature come together?
Uh-oh.
Yeah. Yep.
Yeah.
Ruh-roh. So you see, the mount is now pointing up basically at the North Celestial Pole. You see the streaking of the stars?
You got a new member in here. Kobe just joined.
Hi.
5 minutes ago, so we need to fill him in.
That's because notice that the mount is connected, but it's not tracking. Let's go ahead and unpark it and hit tracking. Now the tracking rate is what's called sidereal. Now we're going to go back over here. Now look what happened to the stars. Give it a second to stabilize. Now the tracking on the mount compensates for the rotation of the Earth, and now the stars are all perfect little dots. We're going to go ahead and turn this off real quick. Yeah, what happens when your dew point and your ambient temperature reach each other is you get fog, and I have a thick fog going on out there. So I'm only going to be able to see looking pretty much upward. I can't see anything probably from 30 degrees or more down to the horizon. So let's go to APT here and shoot an image. Well, I suppose it might be nice if we, yeah, we've got the camera on and it's shooting an image. While we're doing that, We're going to connect the scope. So here's the image that the camera on the main telescope sees. It doesn't know where it's pointing. It thinks it's pointing more or less towards the North Star, but it doesn't know that. So what we have to do is go over here to something called PointCraft. We're going to tell it where the scope thinks it's looking and ask it to look at that image there and see whether or not it can figure out where it's done. And as you see by this compass up here, it's already done that. And we synchronize the telescope to that. And now, when we go up here to Stellarium, we see the Oh! Starlinks going right through our field of view. We're going to do a snap picture right here and see what we can get. I'm doing this as quick as I can. There's a lot of little clicks. All right, I don't see it. Now, unfortunately, at this time, we had to curtail our efforts to hunt some satellites because a thick fog had rolled in over the lake, and it was getting late, so I thought I'd call it quits. We'll do it again on Saturday night, and we should have at least 6 hours of good seeing, so it should be a pretty good session. Take a moment, hit the like and subscribe, and just tune in then. Join us on Discord, and we'll all have some fun looking at the stars together.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Above the science guy, above the science guy.